Welcome to the DIY Honda Garage channel. The error codes P0138 and P0158 indicate a high voltage condition in the rear and front secondary heated oxygen sensors, HO2S, specifically related to Bank 1, Sensor 2, and Bank 2, Sensor 2 of the Honda Pilot model from 2016 to 2022. These sensors play a crucial role in monitoring the exhaust gases to optimize fuel efficiency, reduce emissions, and ensure the engine runs at its best performance. The rear sensor refers to the one positioned after the catalytic converter for Bank 1, while the front sensor is located before the catalytic converter in Bank 2. Both sensors are vital for the engine control unit, ECU, to adjust fuel injector timing and operation based on the oxygen levels in the exhaust gases. High voltage readings from these sensors generally indicate an electrical issue either within the sensors themselves or in the wiring connectors leading to the powertrain control module, PCM. It is crucial to address such DTC errors promptly to avoid further damage and ensure regulatory compliance for vehicle emissions. Both error codes P0138 and P0158 denote issues with heated oxygen sensors in the Honda Pilot. The rear secondary HO2S, Bank 1, Sensor 2, and the front secondary HO2S, Bank 2, Sensor 2, monitor exhaust gases and send real-time feedback to the ECU. If these sensors output a high voltage signal exceeding 1.27 volts, it indicates abnormalities in their function. The significance of the voltage readings is critical because they directly impact the ECU's ability to regulate air-fuel mixtures, which is essential for optimal engine performance. The affected sensors are positioned strategically. The rear sensor is situated after the catalytic converter, while the front sensor is located prior to it. Therefore, a malfunction leads not only to inefficiencies in fuel consumption, but may also contribute to increased greenhouse gas emissions, making this a vital issue to resolve. Several potential causes can trigger the DTC codes P0138 and P0158. A primary concern could be a faulty heated oxygen sensor, which might not provide accurate readings due to internal defects. Additionally, wiring problems such as shorts, corrosion, or broken wires in the circuit might cause high voltage signals to be sent erroneously to the PCM. Poor connections at the sensor or the PCM can lead to intermittent failures or high resistance in the circuit, which may also result in faulty sensor readings. Lastly, a malfunctioning PCM might misinterpret sensor data, leading to incorrect adjustments in fuel efficiency. Understanding these common sources of trouble is essential for effectively diagnosing and resolving issues indicated by these error codes. Diagnosis of the DTCs P0138 and P0158 can be supplemented by the presence of several symptoms. A significant indicator is poor fuel economy, as the ECU may miscalculate the air-fuel mixture due to inaccurate sensor data. Additionally, drivers might experience engine performance issues, such as rough idling or hesitation during acceleration, which can further diminish the vehicle's responsiveness. Increased exhaust emissions are another serious consequence, potentially jeopardizing compliance with environmental regulations. Moreover, the check engine light will illuminate on the dashboard, indicating that vehicle diagnostics have registered a fault. Recognizing these symptoms not only aids in understanding the issue, but also helps prioritize immediate attention to the sensors and associated circuitry. For the first troubleshooting step, you should start by turning the vehicle to the on mode, which powers the onboard diagnostic system without starting the engine. Following this, use the Honda Diagnostic System, HDS, to clear the diagnostic trouble code, DTC, which resets the system and allows for fresh readings. After clearing the codes, start the engine and hold it at 3000 RPM without load, meaning the vehicle should be in park or neutral. This condition is essential because it allows the engine to reach operating temperature and engages the radiator fan, promoting optimal sensor conditions for accurate sampling. After achieving these conditions, check the HO2S signals using the HDS. Specifically, you are looking for voltage readings that should not exceed 1.27 volts. Based on these readings, determine whether subsequent steps are necessary, depending on whether the threshold is met or not. Moving on to the second troubleshooting step, you first turn the vehicle to the off mode. This step ensures your safety while working with the electrical components. Once powered down, you will need to disconnect the secondary HO2S Sensor 2 4P connector, which involves unclipping the connector to isolate the sensor from the system. Subsequently, you will connect terminals A and B using a jumper wire, bridging between the two assigned pins in the 4P connector. Turning the vehicle to on mode again at this stage is crucial, allowing the diagnostic system to power up and read the new circuit configuration. Similar to the previous step, use the HDS to check the HO2S voltage levels. If the readings still exceed 1.27 volts, the sensor likely requires replacement. If they are below the threshold, it indicates that other components may be functioning normally. In this third troubleshooting step, you begin by turning the vehicle to off mode once again. This removes power from the diagnostics and prevents potential electrical shorts during the handling of the components. Remove the previously connected jumper wire from the secondary HO2S Sensor 2 4P connector to revert to its original state. Now, you will connect terminals A and B using a jumper wire specifically targeting the rear bank, Bank 1. Secondary HO2S 4P connector and body ground. Once these connections are made, turn the vehicle to on mode again, allowing the HDS to read the current parameters. The HO2S voltage should still be above the threshold of 1.27 volts. If they fall within the range, this indicates the wiring from the PCM to secondary HO2S is intact. If not, it suggests that further investigation may be required in the wiring or connections themselves. The fourth troubleshooting step begins with turning the vehicle to off mode to safely perform electrical tests. Now, you will use the HDS to jump the Safety Communication System SCS line, which should typically remain inactive. After allowing time for the vehicle systems to settle, proceed to disconnect the PCM connector C, specifically the 51P connection, which handles communication and control for various engine components. With this connector removed, check for continuity between specified test points. This process is essential for diagnosing potential breaks in the wiring between the PCM and the secondary HO2S sensors. If continuity is present, it indicates the wiring is functional, and further inspection may need to focus on other components, such as the PCM. However, if continuity is absent, it suggests there is an open circuit in the wiring that needs to be repaired to ensure the sensors operate accurately. Once you have completed the troubleshooting steps for DTCs P0138 and P0158, it is essential to verify that all repairs were effectively executed. Begin by confirming the functionality of the heated oxygen sensors by ensuring they provide accurate voltage signals within the accepted range. After validating the sensor operations, conduct a thorough check of the associated wiring and connections to confirm they are firmly in place without corrosion or damage. Use the HDS to clear any remaining DTC codes and check for reoccurrences after repairs. After ensuring that everything tests within specifications, undertake a test drive to observe the vehicle's performance under real-world conditions. This assessment assures that the previous issues addressed through the troubleshooting steps are resolved and no further diagnostic trouble codes are present. To prevent the recurrence of DTCs like P0138 and P0158 in the future, it's crucial to establish a system of preventive maintenance. Start with routine checks of the entire exhaust system, including the catalytic converter and associated sensors, to identify any visible damage or corrosion. Conduct regular wire inspections to ensure that connections remain free from dirt or oxidation, which could affect electrical flow and sensor performance. In addition, keep the sensors clean. Contaminants can impact sensor performance and provide false signals, leading to potential diagnostic trouble codes. Lastly, stay updated with any software upgrades that might address known issues or improve the overall performance of the engine's control systems. Effective preventive measures can significantly reduce the chances of encountering similar diagnostic trouble codes in the long run. In conclusion, addressing DTC's P0138 and P0158 requires a structured diagnostic approach, focusing on each step outlined in the troubleshooting guide. Understanding the role of the rear and front secondary heated oxygen sensors is critical, as is the flow of electrical signals to and from the PCM. Monitoring specific voltages during each step ensures that the vehicle's emissions control system functions properly. Additionally, regular inspections of wiring and connections, combined with effective preventive maintenance practices, can help in avoiding similar issues in the future. By implementing these troubleshooting strategies and preventive measures, owners can enhance both the longevity and performance of their Honda Pilot while also maintaining environmental standards. Please like and subscribe to the channel. See you next time.